Good morning, students. Welcome to session 6 on IoT. This is Professor Bosco, PG Department of Computer Science, Sec. College, Tirupattur. Now, let us start with the YouTube questions. One of your classmates has asked a question, so I am going to reply to that question now. The question is, what is the difference between IPv4 and IPv6? 4 and 6 is called a version number. We know Windows 7, Windows 8, Windows 10. All the last numbers are called versions. Like that, in IPv, they have introduced 4 and 6 as version numbers. So V stands for version, and number 4, number 6 stands for the version number, and P stands for protocol. We know already what is protocol is set of rules followed in internet. So I stands for internet. When you read continuously IPv4, that is Internet Protocol version 4, and another one is IPv6, Internet Protocol version 6. The first difference is the length of header field in IPv4 is 20 and IPv6 is 40. That is length of header field. Next is number of header fields. In IPv4 is 12, in IPv6 is 8. That is the number of header fields. Next difference is address method. IPv4 is following a numeric address and IPv6 is following alphanumeric address. What is numeric and what is alphanumeric is? Numeric purely uses only numbers 0 to 9. That is called as numeric address. In alphanumeric, they will follow as 0 to 9 as well as they use alphabets. Example, your register number BP 123. So that is called as alphanumeric because we are using alphabets and we are using numbers. So that is why we call this as a alphanumeric. And size of address. This is a big difference between IPv4 and IPv6. This is using, that is IPv4 is using 32-bit of IP address and IPv6 is having 128-bit of IP address. In many competitive exams, they ask these questions. How many bits are used in IPv4 or how many bits are used in IPv6? So main reason to change from IPv4 and IPv6 is the length of IP address is exceeded. Many years back, our mobile numbers was started with 944, 9623. So like that, all the mobile number were started with number 9, digit 9. So now we are using number 8, 7. So like that we have changed. Why we have gone to 7, 8 as a starting letter, a starting number? Reason is we have exceeded all the numbers with starting with 9. So we have moved to new number following 7, 8. So like that we have changed. Because the population is increased, the number of devices connected to mobile has been increased. So that they have changed to a new numbers. So like that in IPv4 there is limitation. The number of bits is limited. So like an IPv6, the number of bits of IP address is increased. Now let us see today's topics. Logical design of IoT. In that we have three sections: IoT Functional Blocks, IoT Communication Models, IoT Communication APIs, IoT Enabling Technologies. First, let us start with IoT Functional Blocks. An IoT system comprises of number of functional blocks that provide the system the capabilities for identification, sensing, activation, communication, and management. So all these are involved in functional block of IoT. So we need to identify the device, we need to use sensing, and we know activation, and we need to follow communication, and finally you have to manage. These are the various functional blocks in IoT. Let us see one by one. Device. communication, services, management, security, application. So all these are different blocks. We need to use a device. The device supposed to use different communication methods, whether it is local network or it is a global network, whatever it may be. And we should also know what type of service it is going to use. The service is important. And how we are going to manage this called as management. And we know security is very important in any technology, so that in IoT security is also followed. And what type of application you are going to provide to use IoT, that is about application. So all these blocks are very important in IoT. The next topic is IoT communication models. There are four different models followed in IoT. We shall see one by one. First one is request response. Next one is publish subscribe. Next is push pull. The last one is exclusive pair. The first communication model is request response. We know request is always given by client and response is always given by a server. Moreover, a client is a program and server is a program. So one program is going to respond to another program. The program which is giving request we call as a client. Program which is handling the request is called a server. This is a small introduction about client and server. So always client is going to give request to server and server will process the request. What is the process? Whether it is requesting any resources or any services, so like that the server will process all the requests. While server is processing the request, if client has requested any resources, then the server will find or fetch the resources requested by a client. So then it will prepare a response messages so that the server will notify or server will respond to the client that the requested resource is available or the requested resource is not available. So this is called a client server or request response communication model. So as you can see this image, there is a request, there is a response. So in the response we'll be having whether the resource is allocated or whether the resource is not allocated. So this is how the request and response communication model is working. Now we shall see the next communication model, that is publish subscribe. Here we have publisher as well as subscribers. So publisher will send messages with various topics, and there is broker. The broker is in charge of saving all the topics. If publisher is sending new messages or new topics, all the topics will be saved in broker. It is like a server. So broker will be having all the topics. So we can call for each topic there will be a different subscribers. So example, if you take topic 1, here they were given two consumers. So topic 1 has got two consumers, topic 2 has got consumer 3. For publish subscribe communication model, we can take real-time example, that is YouTube channel. You know, I'm running a YouTube channel, that is Valayosai. So in that I am publishing all the IoT videos. So here I am the publisher, person who is creating videos or who is uploading videos is called a publisher, and you are all called as consumers. When you become consumer is when you subscribe to my channel, you are becoming a consumer. If you are not subscribed, you are not a consumer, right? I hope you are able to understand. So I am the publisher, I am sending different topics. So last class we have seen physical design of IoT, and this class we are seeing about logical design of IoT and other topics. So I am uploading at different topics, so you are able to listen to the topics, you are able to learn out of this YouTube channel. So that is called a small example for your published subscriber. So publisher will create different topics or different messages, and YouTube channel is handling all the topics and all the videos, and you are able to view from the YouTube channel. So this is a small example for publish subscribe communication model. I hope you are able to understand this. The next communication model is push pull. Here we have publisher and also we have consumer. Publisher is in charge of sending messages and consumer is in charge of receiving all the messages. So in between publisher and consumer we have a queue. So we have to insert all the messages in the queue, that we call it as a push, and from the queue consumer is able to read all the messages, that we call it as a pull. We know the real meaning of push and pull. When the message is inserted into the queue, we call this as push. When a message is read from queue is called as pull. This is like a pair. When you use push, automatically there will be a pull. So this is the push-pull communication model. This is exclusive pair communication model. Here we have client as well as server. So every time the client will give request and the server will give response. So we shall see one by one. The first request to set up connection is given by client and server will give response that accepting your request. Next, the client will send a message to server, and from server the client will receive a messages. So finally this connection is going to be closed, so that the client is going to send message as closing the connection and the server will respond that going to close the connection. So for every communication there will be a reply, so that it is called as exclusive pair communication model. If I send request, I'll get response. If I send message, I'll get message. So this is following a pair. Pair is two. When I send a message, I'll get a reply message. When I send connection request, I'll get accepting the connection. When I sending closing request, I'll get closed response from a server. We're going to send message from client to server. Before sending a message, I have to develop a connection. After sending a message, I have to close the connection. For that purpose, this model is used, that is exclusive pair communication model. In logical design of IoT, we have last topic as IoT Communication APIs. There are two APIs, one is REST based, another one is Websocket. We shall see one by one. The first one is REST based communication APIs. REST stands for Representational State Transfer, is a set of architectural principles by which you can design web services and web APIs that focuses on systems, resources, and how system resource states are addressed and transferred. In the internet, many applications are following this REST API, and this is one of the successful APIs, so by which you can send data over the internet as well as you can receive data over the internet. So many applications are using this REST API, and main concept involved in REST is JSON as well as XML. Both are data sending formats as well as data receiving formats. And this is also focusing on system resources and how system resource states are addressed. So those things are handled in REST API. And this is also following a request response communication model. This already we have seen in our previous slides. Now we shall see REST architectural constraints. So REST is following client server, that is the request response model that you know already. Next is a stateless client server communication. The principle behind the client server constraints is the separation of concern. So client is having some task as well as server is having some kind of tasks. Both are not equal, both are separate. Stateless Each request from client to server must be contains all the information necessary to understand the request. To understand stateless features of REST API, we can imagine or we can take an example as ATM transaction. So in the ATM, we go and swipe our card, we give all the details, account details, and we take money. Imagine there is a situation where you have inserted a card and you have entered your PIN number and you are about to enter the amount. Say example, you are going to withdraw 1000 rupees from your account. So while entering the number, there is some system failure. Then who will take in charge of this system failure? That is, the ATM machine is restarted or some other problems. So in that situation, whether the ATM will take in charge or the user will be in charge of the mistakes. So there they follow this stateless design because the ATM will not maintain any detail. If your transaction completes only, you are able to get money. If your transaction is failure in between, that is while entering password or while entering your amount, so that situation you are the responsible. That is a client side, you are the responsible for all the risks. The server will maintain only if the transaction is successful only. The amount 1000 rupees will be deducted from your account and 1000 rupees will be dispatched to your ATM machine. So I hope you are able to understand. When the transaction is fully in charge by the client side, it is called stateless. When the transaction is fully in charge of server side, that is called stateful. The next constraints of REST API is catchable. Catch constraints requires that the data with a response to request be implicitly or explicitly labeled as catchable or non-catchable. Here, the client and server are going to communicate. While communicating, whether the data is saved in a temporary place or the data is not saved in temporary place, that is called catchable or non-catchable. Next constraint is layered system. So layered system constrains the behavior of components such as each component cannot see beyond the immediate layer with which they are interacting. So in layered system, not only here, in all the layers, if you take OSI layer or IoT layers, so all the layers following some set of rules. In every layer system, if I am in a particular layer, I can go one step back or one step forward. That is, I can communicate with my previous layer or I can communicate with the next layer. So this is the simple rule followed in all the layered system. If we take example of IoT protocols, IoT layers, we have four different layers. First top is application layer, next we have transport layer, next we have network layer, next we have physical layer, that is link layer. You can take any layer, so that layer is able to communicate with the next layer or it is able to communicate with the previous layer. Any layer cannot communicate more than one more layers, that is one step, more than one step you cannot go. Let us imagine that we are in a link layer, that is bottommost layer. So link layer is able to communicate with next layer, that is network layer, and link layer cannot communicate with either transport layer or application layer. So the limitation is only the next layer, not more than one layer. So kindly remember, not only for IoT, for any layered system, one layer is able to communicate with the next layer or the one layer is able to communicate with the previous layer. That is a system followed in all layered system. Uniform interface. Here we have client as well as server. So both client and server should follow some uniformity for the transaction, follow some uniformity for communication. So next is code on demand. If a client is requesting some code to execute server programs, The server will send all the codes and script to client to run as server programs. That is about code on demand. Explaining about architecture of REST API. This is the diagram of REST API. You can see in the left topmost corner. Here we have HTTP client, HTTP server. So in between HTTP server and HTTP client, we have HTTP packets, because from client to server there will be message passed every time. So the message is consist of HTTP commands, that is get, post, put, get. These are HTTP commands. We know get, all the detail will be visible in the URL, and that is known as get. Post, no detail will be viewed in the URL, that is called post, and that is put and delete also. Another important thing is REST payload. So all the communication is done through JSON as well as XML. These two are a data exchange format. If a client is sending any message, any data, that is transferred either JSON or XML format. If server is sending message or data, that is transferred by means of JSON and XML. So if the client is requesting some resources, so this follows some rules. That is, the client message will reach to server. Server will check whether the requested resources is available or not. If the available resource is okay, then this resource will be allocated to a client. It is like a small client server communication. Client is requesting the resource and server is giving the resource to client by means of HTTP packets based on get and post by means of JSON and XML. So this is how this REST API is working. This diagram shows a detailed communication between a client and server based on a request response model used by REST. That is, client always give request based on get, put, update, delete with this. With a payload, as I told you, JSON or XML, these are two data exchange formats, will be sent to server. Server also will give response based on JSON or XML. Request again sent to server, again the server will give response to a client. This is a model which we have already seen, that is request response model. Client will always give a request and server will always give a response. Our internet is working based on this model only. In IoT communication APIs, we have the second topic is Websocket based communication APIs. Websocket APIs allow bidirectional, full duplex communication between client and server. It follows the exclusive pair communication model. WebSocket APIs reduce the network traffic and latency as there is no overhead for connection setup and termination, request for each messages. So this is one of the successful communication like REST API. So it follows exclusive pair communication model. This also we have seen in our previous slides. For every request there will be a reply. The next topic is IoT Enabling Technologies. There are 5 technologies listed here, and this is an example only. There are many more technologies which is supporting IoT technologies. Embedded systems, wireless sensor networks, communication protocols, cloud computing, big data analytics. We shall see one by one. First technology is embedded system. We know what is embedded system. That is, an embedded system is a system that has computer hardware and software embedded into perform specific tasks. So embedded in the sense software and hardware will be bundled together to work or to perform some specific task. That we call it as a embedded system. We shall see some examples. We are using digital watch, digital cameras, vending machine, appliances, that is washing machine, microwave oven. So all these things are embedded systems where we have hardware as well as we have software. Both hardware and software are bundled together to perform specific task, that is called embedded systems. Next is wireless sensor network. In short form we call as WSN, comprises of distributed devices with sensors which are used to monitor environmental and physical conditions. That is, this wireless sensor network is in charge of checking all the environmental or physical conditions. It will send the messages to the server. So there will be different sensors located in different places. So all the sensor will be sending different details to the main server that this is the environmental changes. Example, if there is any rain is coming, this is previously notified by this sensors. That is called wireless sensor network. A wireless sensor network consists of number of end nodes and routers and coordinators. So collects the data from all the nodes. There will be different nodes. So each node will be sending different data. So to understand wireless network, there are simple examples. Weather monitoring system, soil moisture monitoring system, and surveillance system. Okay, in soil monitoring system, there will be sensor insert into the soil. So the soil will be checking the moisture level. If the moisture level is low, then it has to pour some water to the particular soil. So that is based on wireless sensor network. Next topic is communication protocols. This is already we have seen, that is IoT protocols form the backbone of IoT system and enable network connectivity and coupling to applications. Communication protocols allow device to exchange data over the network. So this protocol is going to help the IoT to exchange data over the network. Next is cloud computing. Cloud computing is transformative computing paradigm that involves delivering applications and services over the internet. Cloud computing is mainly in charge of three services. One is infrastructure, another one is platform, another one is software. So what is infrastructure? Infrastructure is all your processor, RAM, hard disk. So everything will be called as infrastructure. If you want a 2 GB RAM, you can buy through online, through internet. And if you want a 10 GB of hard disk, you can buy it through internet. That is infrastructure as a service in cloud computing. And platform, we know platform is called as all the operating system. Example, Windows, Linux, Macintosh. So everything is called as platform. All the operating system are called as platform. So we have infrastructure means we'll go for platform. So after using a platform, we'll use some software, maybe application softwares. That is called as SaaS. That is software as a service. So infrastructure is your system, operating system your platform, and all the application softwares. Word, Excel, PowerPoint, everything is called as software. That is application software as a service. So IoT is mainly relying on cloud computing. That you need to remember. Next is big data. Big data is collection of data sets whose volume, velocity, variety is so large that it's difficult to store, manage, process, and analyze the data using traditional database and data processing tools. So big data is a big topic. There are three V's. We call it as volume, velocity, variety. Volume we know the size 1 GB, 2 GB, 3 GB, that we call it as a volume. Velocity is how often the data is generated, that is called velocity. And variety is different types, that is structured data, semi-structured data, unstructured data, that is called as variety. So some of the examples in IoT, that is weather monitoring stations, machine sensor data from industrial system, health and fitness data, location and tracking system. So all these are using big data. So as you see, big data is not a size. Big data is use of volume, velocity, and variety. Now let us recall today's topics, that is logical design of IoT. In that we have seen IoT functional blocks, IoT communication models, IoT communication APIs. The last topic is IoT enabling technologies. We have seen some of the technologies: embedded system, wireless sensor network, big data, cloud computing, communication protocols. I hope you are able to understand this session. Thank you.